Hey everybody, this is Alex Merced from alexmercedcoder.com, and I just wanted to do a quick video on the concept of memoization. So memoization is a functional programming concept, and the basic idea is this. If I have my function do all the things that my function does over and over and over again, okay, it's going to end up using a lot more processing power because I'm just repeating that function over again. And there's situations where that happens a lot, like in React. In React, every time your data changes, you are if you're using functional components, a function's rerunning and rebuilding your DOM. So there's techniques like memoization, which helps you sit there and say, hey, if the data hasn't changed, like if the things that this function needs hasn't changed, why do it again? So for example, let me create a function, const add nums equals equals an arrow function that takes two arguments, x and y, and then just returns x plus y. Okay, so there's add nums. There's the function. Now here's the thing. If I do add nums 1 1, let me console log it. Console.log. Control C. And if I do this function 3 times, I'm literally just adding 1 and 1 3 times. Oops, that's the wrong thing. I want to do node scratch.js. See, I'm getting the same number 3 times, but it actually did the process. It did the calculation 3 times. So that's fine for like a really simple function like 1 plus 1. But what if you have this like function that's like, a very large, complex, process-heavy function? Okay, where you're doing really complex data transformations. You don't necessarily want to do the same transformation for the same data over and over again. And this is where memoization becomes really useful. And the things that do memoization, you really need pure functions. Okay, where basically, given the same inputs, you always get the same output. So basically, so that means if we know that if this were a pure function, which it is, because hey, if I give 1 plus 1, I'm always going to get 2. So this is a pure function. Given the same inputs, I'm always going to get the same output. Given that, I know then in that case, if I get the same inputs again, why should I run the function again? That's sort of what we're getting at with memoization, trying to say, okay, hey, only run the function if you're giving it different inputs, because we're going to cache the old results. So let's create the memo wrapper. Okay, so const, we'll create a function called create memo. Okay, it's going to return a memoized version of the function. Okay, and basically what it does, it takes one argument. We'll call it the function, the func. And essentially what it's going to do, okay, is whenever this, it's going to return. What we're going to do is we're going to actually create an object. So const results equals an empty object. And essentially this is going to be our cache. So actually let's call it cache. Okay, here's where we're going to cache all our results. So every time this function will run, we'll save a version of this there. Okay, and then basically what happens is that this function returns a new version of the function above. So it's going to return you a function. Okay. That takes in, let me think about how I want to do this. It takes in it takes the function that you pass in. Okay, and it'll spread the args. So we're going to use the rest operator to get all the arguments that you pass in. And then basically what it's going to do, it's going to say that cache, okay, cache, the object, and if we take a string version of the array, so let me remember how I would do that. I think it would be like, what, args to string. So that's going to be the key. So that's how we know like if it's the same arguments, because this args to string would end up being the same string. Okay, we're going to say that the value of this will be the results of the function. So we say the func being given args, but this time we're spreading args, so that way they're individual arguments. Okay. So essentially, if the arguments are the same, I'm going to end up doing the same value here. Okay. And actually, we don't want to do that every time. We only want to do it if it hasn't been done before. So we do if. So if this string already exists, so like if this property already exists in the object, then we only want to return the cached value. So we'll return that. Okay. Now, else, if that property is not in the object, which means we've never used those arguments before, then we will do this. Okay, we'll actually run the function and then return the value of that. Okay. Cool. That should do it. I could optimize this a little bit more. So what I could do is I could say args const arg string, because right now I'm doing this whole toString operation over and over again. Let's not do that. Let's just do it once. So let's cut that out here. And then we're just going to use this in here. Okay. Now, just to kind of see, so you can see when it does. So basically, when this is the situation, we're going to use the cache. So we'll console log use cache. And then here we'll console log use function. So that way you can see that if I run the same function multiple times. Okay, cool. So we created this create memo function. So this create memo function, again, what is it doing? It is going to create this function using the function we passed in that caches the results. So now what I would do is I want to use my create memo function. So I'm going to say const memo add nums. So it's the memo version of add nums equals create memo add nums. So I pass add nums to it. And this is going to give me that new sort of super cached memoed version of add nums. And I could do this with any function now. Okay, so then I would, let's use memo add nums. So we'll say console.log memo add nums 1 and ideally is the first time I do this, since it's the first time I use 1 and 1 as arguments, I should get like use function, then use cache, and then I do it again with a different set of arguments. So we'll say 1 and 2. I should get the same process again. So let's try that out. Okay, and yes, it works. So you see the first time I use that set of arguments, okay, the first time I do that, it actually does the full operation, and the second time it just returns the cached results. So that means the first time it's doing all the work, but the subsequent times it's doing less work. Now let's test that out. Let's say, let's do a console.time. Console.time. Call this memo as the name of the timer. And then at the end, before we return, console.timeEnd memo. Okay, so we can see how long each time takes. Let me think about that. Console.time memo. Oh, because that's not going to run each time, so I need to put that also in here. Console dot time end memo. Okay. Cool. Let's run that again. Okay, so you see here, let's take a look. See, the first time we used the function, that took about 2.678 milliseconds. And see, the second two times is just giving you the cached results. So that's a bit quicker. Okay, in this case, it uses the function, so it took 0.35 milliseconds, but you see the second two times it was a little bit faster. So for some reason, adding 1 plus 1 takes a lot longer than adding 1 plus 2, which is interesting. Okay, but you can see like it speeds up, like especially with 1 plus 1. Like let's say I replace this all with just add nums. So just to kind of, well, yeah, I think you guys get the point. So the idea is like this would be how it would take like each time. And now look, I've cut over 2 milliseconds out of each use of that function because I memoized it. So now imagine much, much, much more complex functions and the time you could possibly save by memoizing functions. But again, it only works if it's pure. If it's an impure function that depends on external stuff, meaning basically it has like side effects, then what happens is you can't memoize it because there's other things at play. This is why writing good functions that are pure, that, again, everything stays within the function. If you need anything from the outside, you pass it in as an argument, then you can do this, and you can then, again, save speed. But yeah, that's all memoization is. So if you're looking in React and you see like that use memo hook or use callback hook, all those are doing is memoizing callbacks, memoizing different processes, so that way you're not doing the same operation over and over again. Okay, a lot of what's going on in React is just a lot of memoization. This way you don't end up doing the same thing over and over again, because React relies on a lot of functional concepts. But this is something you can use in any kind of coding you're doing. Okay, and again, see, it's not a lot of code to write this function to memoize any function. Like this now would work with any function I give it. I can create a memoized version of any function. I did the thing. Okay, and I could probably write this in a quicker way somehow. If I use some ternary operators, but I think this is pretty explicit. So let's try something I haven't done before. I haven't really used a gist before. Gist.github.com. If I remember right, these are just so you can write quick things. So let's do that. I'm going to create a gist so that way I can post this. And let me just put a little heading here. Example of memoization by Alex Merced of alexmercedcoder.com. Okay. So let's copy this, so that way I can share it with you guys at the end of the file. So we'll call it memo.js. Okay, example of memoization in JavaScript. Okay. Then I want to create a public gist. So I think that does it. Do I have, if that works, and there we go. We've created a public gist. Okay. So I will share this in the video description, so that way if you want to look at this code, it'll be right there for you to analyze. But yeah, have a great one. And again, make sure to head over to devnursery.com and alexmercedcoder.com. Sign up for the Discord and Slack channels. Subscribe to this YouTube channel. Subscribe to my podcast. Follow me on Twitter. All the things. Do all the things. Well, otherwise, I'll see you guys later on.